Okay, so in this video we are going to look at covalent bonds. So we discussed in the previous video that atoms normally combine to form bonds and molecules because they want to gain more stability, and when they bond they are basically trying to acquire electron configuration similar to those of noble gases. So noble gases here in the last column, last group 18 of our periodic table, and we have seen that their electron configuration has 8 electrons, consists of 8 electrons in the valence shell. For ready reference, let's write the electron configurations here. So helium has got 2 electrons, so that's the first shell. Neon we got 2 and 8. Next is argon, which is got 2, 8, 8. Krypton 2, 8, 18, 8. And we see that all the noble gases other than helium have 8 electrons in its outermost shell, in the valence shell. And when atoms combine, basically they are trying to gain, they're somehow trying to have 8 electrons in their valence shells. So in the previous video we saw that atoms could manage to have 8 electrons by either giving up electrons completely or accepting electrons. So if we look at sodium here, sodium can acquire electron configuration of neon here by just giving 1 electron. So sodium would normally give an electron and would form a positive ion. On the other hand, if we look at chlorine, we see that chlorine can acquire electron configuration of argon by just gaining 1 electron, and in that way it would form a negative ion, and the bond between sodium and chlorine would be a ionic bond. Let's consider what would happen when hydrogen and chlorine combine. Hydrogen and chlorine combine to form hydrochloric acid, HCl. Let's see how they would combine, how they would manage to get electron configurations similar to noble gases. So hydrogen has got only 1 electron, and that is in its outermost shell. There's only one shell number 1. And chlorine has atomic number of 17, so its electron configuration is 2, 8, and 7. Now hydrogen here can gain electron configuration similar to that of helium, which has got 2 electrons, so it needs 1 electron here. And likewise chlorine has got 7 here, and chlorine can gain electron configuration similar to argon here by just gaining 1 electron. So we see that both of these atoms, they need an electron, they need to gain an electron. Now when they combine, neither of them is willing to give up an electron. So the only option left for them to acquire an electron is to share electrons. When atoms share electrons, they count the electrons contributed by other atoms as their own, and that way they are able to have electron configuration. How that happens? Let's take a look. So we are looking at HCl. So we are going to write their electron dot diagram. So electron dot diagram is, you got a symbol of the atom, and then we show the electrons that are available in the valence shell. So here in hydrogen there is only 1 electron, so we just need to show 1 electron. Chlorine has got 7 electrons in the outermost shell, in the valence shell, so we need to show 7 electrons. In subsequent videos we would look in more detail on electron dot diagrams, because at times they can be tricky. So chlorine has got 7 electrons, so we write them like this, and that's the 7 electrons. So 1, 2, 3, 4, 5, 6, and 7. So when hydrogen and chlorine combine, they share 1 electron each, and that way hydrogen would acquire 1 electron, so to say, and chlorine would also acquire 1 electron, and both of them would have electron configurations similar to noble gases. How that happens is, we can show like this, or I think I'll use a different symbol for showing electron of hydrogen here. So this is how I am showing here. So that's a hydrogen electron. Hydrogen had contributed 1 electron. That's chlorine has contributed 1 electron. And so these 2 electrons are shared electrons, and shared electrons are counted by both the atoms as their own. So we see that hydrogen now has got 2 electrons and chlorine has got now 8 electrons. So both have electron configurations similar to noble gases. And this kind of bond, which is formed when electrons are shared, is known as covalent bond. So in covalent bonds, we see that here H and Cl, they have a unique identity. They are basically a separate entity, and we have a molecule here. Covalent bonds therefore basically results into molecules, and covalent substances are normally molecular substances. Depending upon this, we can also look at their properties. Let's before we go and look at the property, let's look at one more example. When oxygen and oxygen combine, then we'll see that they also share electrons. So let's first, or better still, let's take another example. Let's take example of carbon and oxygen. So carbon here has got electron configuration. Let me write carbon electron configuration here. Carbon has got atomic number of 6. So it has 2 and 4 electrons, and oxygen has 2 and 6. So we see that carbon here needs to gain 4 electrons, and oxygen here needs to gain 2 electrons. So we need to see how the needs of both of them can be satisfied. Carbon needs 4 electrons, but oxygen is willing to share only 2, which means that to satisfy both of them, we will need 2 atoms of oxygen and 1 atom of carbon. So let's first write the electron configuration here. Lewis dot structure, dot diagram. So carbon has got 4. I'll again use a different symbol for the electron. 1, 2, 3, and 4. And oxygen has got 6 electrons. So 1, 2, 3, 4, 5, and 6. Now when they combine, I see that oxygen is willing to share only 2 electrons, but carbon needs 4. So one carbon atom will bond with 2 oxygen atoms. That way this carbon atom would gain 4 electrons, and it would gain electron configuration of a noble gas. How it is done? Let's take a look. So this is my C. It shares 2 electrons with 1 carbon atom, 1 oxygen atom, and 2 electrons with other oxygen atoms. So here this oxygen contributes 2 electrons, 4, that's 6 for this oxygen, and this, let me show oxygen here, and oxygen shows these electrons, not very properly drawn there. So these are the electrons contributed by the carbon, and these are the electrons contributed by the oxygen. So these contributed electrons are counted by each atom as its own. When you do this, you see that, I made a mistake here. So go there. So when you see that this carbon has got 4 electrons here and 4 electrons here, carbon got 8 electrons in its valence shell, and oxygen also has got 4 here and 4 here, 4 and 4 here. They have got their full octet in the valence shell. Now drawing electron dot diagrams like this is a bit cumbersome, so the convention that we follow to show covalent bonds is by showing sticks. So one stick basically is one pair of shared electrons. So here we can show HCl as HCl. This carbon here, carbon dioxide, we got 2 bonds with oxygen, so we got 2 sticks here, and 2 bonds with oxygen, we got 2 sticks here. That's your carbon dioxide. Now let's look at properties of covalent substances. We see that covalent substances are molecular in shape. If you recall, ionic substances, we had no molecules. So here in covalent bonds, we have distinct molecules, and these molecules are described as discrete, as each molecule is separate and distinct from the others. So basically, if you are capable, if you have technical equipment, you can separate one single molecule of a covalent substance. Now these substances have low molecules and boiling points. All the properties here basically they come from intermolecular force between covalent molecules. In ionic substances, if you recall, we had ions which were very strongly held together with each other. But in covalent substance, you got discrete molecules, and the force between these molecules is not that strong. And this particular feature will describe so many properties of ionic substances. So first thing, they have very low melting and boiling points. So here when you're trying to melt or boil a covalent substance, you're trying to separate molecules. And these molecules are not so strongly held. Therefore, you need to provide only little amount of energy and they would melt or boil. So boiling, which means that boiling and melting points are very small. Again, next property is that they are soft. Again, it comes from the fact that the intermolecular force between covalent molecules is not so strong. Mostly they exist as gases or liquid at room temperature, obviously because they have low melting point and boiling point. So even at room temperature they would have melted and they would have boiled. So you would find them in gaseous state or liquid state. Generally, they are poor conductor of electricity. I don't think I need to explain much on this. I need to explain this much because we know that to conduct electricity, you need charged particles, and those particles need to be mobile. So here we got covalent molecules which are not charged particles, so they do not conduct electricity. I would suggest now that we look at videos, and if we look at some questions. Where are my questions? Okay, so some questions here. Let's say determine first one. I would suggest that you pause the video here and try these questions. The first question is determine whether these pairs would form covalent or ionic bonds. So always first thing you need to do is when you are given these kind of questions, you need to see whether these atoms need to gain electron or lose electron. If one of these atoms need to gain electron and other one needs to lose electron, then the complete transfer of electrons would take place from one to the other, and you would get ionic substances. But if both the atoms need to gain electrons, then the only way they would combine would be to form covalent bonds. So let's look at first one, sodium and fluorine. Sodium has electron configuration of 281, and fluorine with a electron configuration of 9 has got 2 and 7. Now here sodium needs to get rid of this electron and fluorine needs to gain. So obviously the complete transfer of electron would take place. We would get sodium ion and fluorine ion, and the bond would be ionic. Let's look at magnesium and chlorine. So magnesium, atomic number of 12. You have electron configuration of 282, and chlorine 2, 8, and 7, atomic number 17. So we see that magnesium needs to lose this electron. It can, and chlorine needs to gain 1 electron. So this needs to lose, this needs to gain. So magnesium donates 2 electrons to 2 atoms of chlorine. Complete transfer of electrons takes place. This one become a positive ion, that one become a negative ion. So that would be ionic. Carbon and oxygen, we just saw in the previous, in the video that carbon and oxygen, both of them need to gain electrons, so they will be covalent. Calcium and oxygen, so calcium needs, calcium electron configuration is 2, 8, 8, 2, and oxygen electron configuration is 6. So we see that calcium needs to get rid of this electron, these 2 electrons, and oxygen needs to gain 2 electrons. So complete transfer of electrons would take place. We would get positive and negative ions, and the bond would be ionic. The other remaining questions I would suggest that you try on your own. Question number 2 is, I want you to take a look at question number 2 and then pause the video to see, to determine whether these are ionic substances or molecular substances. It's gone off the screen, so determine. Okay, let me just press enter here so that, sorry. Okay, so first one is, a substance has very high melting point. It does not conduct electricity in solid state. However, it becomes conducting in molten state. Now, all these characteristics, all these properties are of ionic substances. Likewise, next one is, a substance is soft solid. Is it soft? Not has. It is soft solid at room temperature, and it is a poor conductor of electricity, which means obviously that it is a covalent substance. And that's where we are going to stop today.